Alright, so let's now build something out of modules. Now, I will admit that we've already met modules when we looked at the register assembly modules method that we had in the builder, when we also looked at registering just ordinary components from the assembly. But this time around, I want to build a bit of a better scenario for us to work with. It's actually a scenario that's available in the AutoFac documentation itself. I've modified it a little bit in terms of the terminology, but apart from that, it's almost identical. So here's the idea. Let us suppose that we have this idea of a truck, and the truck needs a driver. So for all of those, we have certain interfaces. For example, we have an interface iVehicle, which has a single method called go. In addition, we'll have an interface for the driver, so iDriver, and that will have a void drive method inside it, and that's all it will have. And then we'll have two types of drivers. So we'll have a sane driver, a driver that drives within the speed limit, and then of course we implement iDriver, and we have to implement the missing members, and we'll just right line the fact that this driver is driving correctly, so driving safely to destination. And then we'll have a different kind of driver, so let's make a derived type, and this is going to be a crazy driver, and this driver is going to endanger everyone and is going to go over the speed limit and whatnot. So I will right line going too fast and crashing into a tree, which often happens to people who speed. So here we go. We have some sort of setup. What we can now do is we can set up a module which gives you a driver depending on the configuration parameters provided into that module. So the configuration isn't going to be through passing parameters into the interfaces or the actual drivers themselves. Instead, we're going to have a module that actually happens to be configurable. So that's what we're going to implement. But before we do that, we need a vehicle of some kind. So let me go here and I'll make a derived type. So this is going to be a truck. Now a truck needs a driver, obviously, among other things. So we'll have iDriver driver like so, and then we'll have the initializing constructor as always, and in the go method we'll just have driver.drive. That's pretty much it. So it's just a bit of delegation here. Okay, so now we have two drivers and we also have a vehicle implemented. So now we can build our module. So we'll build a transport module, which is going to take care of the various modes of transportation and the drivers which actually drive you. So it inherits from module, which is an AutoFac type, and then of course you can do an override, and what we're going to override is the load method. So here is load. I'm surprised it doesn't give me a hint to actually autocomplete this. Oh, here it is. There we go. Load like so. Okay, I'll finish it in just a moment, but we need to actually make it configurable. So let's suppose that you want to decide whether or not this module specifies a speed limit. So do you want to obey the speed limit or not? So let's make a public Boolean property called obey speed limit. Okay, so this is something you can configure externally. So when you load the module, when you construct the module, you can actually configure whether obey speed limit is equal to true or to false, and depending on that, you can load a different kind of driver. So this is how it would look like. So you check obey speed limit, and if you do want to obey the speed limit, then you register a sane driver as an iDriver. So you say builder dot. You'll notice the builder is being passed into the load method here. So the load method is, well, just as the name suggests, it gets executed whenever you actually load the module. It takes the overall container builder, and then you can do something on that container builder. So here we'll register the type sane driver like so as an iDriver, and that's the good scenario. Otherwise, if we have a no requirement to obey the speed limit, we can hire a crazy driver, save some money, endanger some lives, maybe kill somebody, I don't know. Hopefully not. Register type, and it's going to be a crazy driver, and it also as an iDriver like before. There we go. Let me get rid of these extra braces that we don't need. Okay, and then of course we have to register the truck as well. So we can say builder.register type truck as iVehicle. There we go. Okay, so the registration for the transport module is done, and then all we have to do now is to actually load this transport module when we make our container. So var builder equals new container builder. There we go. And then for the container builder, we say builder dot and then register module. So instead of registering a type, we register a module. Now you can see that there are different overloads here. We've seen register assembly modules previously, but we also have register module, and there are different ways of doing it. I'm going to go with the one that's non-generic because I want to show you how to add that speed limit thing. So as you can see, the argument is just an I module. So here I can make a new transport module, like so, and I'm not going to provide any arguments to begin with, and then using var c equals builder.build, I'm going to actually construct a vehicle and make the vehicle go somewhere. So I'll say c.resolve iVehicle and then .go. Okay, now for now we're going to have the base speed limit property set to false. That's the default value of a boolean. So if we execute this, let's see what happens. Okay, so as you can see, because the base speed limit is false, that means that we get a crazy driver, and so we're going too fast and crashing into a tree. Now what I can do is I can change that parameter. So here I can put curly braces instead, and I can say a base speed limit equals true. And this time around we're going to get a nice sane driver, and if I execute this, you can see that we're driving safely to destination. So that is the gist of how you use modules. So essentially you can make this separate component which defines, for example, the way that things are registered, and can also be configurable. Now the benefits here are numerous, as we've already discussed. One of the benefits I want to highlight is the fact that the public properties of the module give very clear hints as to the kind of things that you can actually control. So you personally don't have to deal with sane drivers and crazy drivers. You can think of it as an external system which simply gives you what you want, depending on the arguments which are actually exposed.